Okay, let's consider the problems on this skill practice 33. Consider the following consumption reaction. All right. We're going to use 125 grams of C4H10 and we're going to react it with 415 grams of O2. Which substance is the limiting reactant? So we have these two. What you need to do is pick one of the products and decide and do stoichiometry with both those amounts, and the amount that gives you less product, less of that certain product is the limiting reagent. So if we take, let's see, 125 grams of C4H10, right? We're going to say how much, I'm going to pick CO2. I'm going to see how much CO2 I get. All right, so I have to figure out so many grams of this in 1 mole of C4H10. And now, here we use the mole-to-mole stoichiometry from the balanced equation. So for every 2 moles of C4H10, we get, I better make sure I can see that. Oh, I think that's 8 moles. 8 moles of CO2. Now, I could be answered here in moles of CO2, couldn't I? So if I figure out the molar mass here, I have 4C, which is 12.01, plus 4.04. So this is 52.08. Now, let's say I start with 415 grams of O2. Now, I do know this is 32 grams of O2 and 1 mole of O2, and then 13 moles of O2 for every 8 moles of CO2. So I can go right to moles. I don't have to go to grams necessarily yet. So if I calculate the top, 125 times 8 divided by 52.08 divided by 2. This tells me about 9.6 moles of CO2. Down here, this tells me 7.98 moles. All right, so O2 is the limiting reactant. And then what mass of CO2 and H2O can be produced? Well, we have the moles of CO2, don't we? So 1 mole of CO2 is 32 plus 12.01, right? 44.01 grams, so times 7.98. So I will make 351, I'm going to say 0.20 grams of CO2. Now let's do the same calculation. We're going to start with 415 grams of O2, and we're going to work with how much water will be produced. 32 grams of O2, 1 mole of O2. For every 13 moles of O2, I get 10 moles of H2O, and then 1 mole of H2O is 18.02 grams. So 415 divided by 32 times 10 divided by 13 times 18.02. I think the answer will be 179.77 grams of H2O. Just check the math. All right, so we had to do 2 things here to figure out what was the limiting reactant. Next one. When 412 grams of calcium carbonate react with this much aluminum chloride, how many grams of each product can be made? Well, we gotta pick a product. We're going to start with calcium carbonate, CaCO3, reacts with 512.9, AlF3. All right, I'll pick CaF as my product. That's calcium. Here's my calcium, has 40.01. My iron has 55.85. So I do know my molar mass of this. 40.01 plus 55.85. 95.86 grams per mole. So over here, I do have calcium at 40.01. I got a carbon at 12.01, and I get 3 times 16, don't I? 16 times 3 plus 12.01 plus 40.01. This is 100.02 grams per mole. And let's look at ALF. AL, 26.98 it looks like. And F times 3. It's really 19.00 times 3. So 19 times 3 plus 26.98. So I believe this one will be 83.98 grams per mole. All right, let's do some calculations. So I just figured out over here, this is CaCO3. For every 100.02 grams, I get 1 mole, CaCO3. And remember, I'm using this as my product right now, the product I'm headed toward. So every 3 moles of CaCO3, I actually get 3 moles of CaF. Oops, I calculated that wrong. I thought that was Fe. It's actually F2, isn't it? I don't know why I did that. So let's try that again. Fluorine, we said was 19 times 2. So this will be 40.01 plus 9. Oh, this is 78.01. Okay, sorry about that. F2. Now I can stop there for moles, so I'm going to do that for a second. So let's go here now. For every, we figured this out, 83.98 grams, I have 1 mole of AlF3, right? Yep. And then 1 mole, oops, let's do say AlF3, 2 moles of AlF3 for every 3 moles of CaF2. So let's look at the moles first. Whoops, what did I have here? This should be a 3. All right, so 412.5. So it looks like I have about 5.29 moles here of CaF2, right? Over here I have times 3 divided by 2. Woo, over here I have 9.32 moles. All right, this is our limiting reactant, isn't it? So now, see, my eraser doesn't work anymore. That's too bad. So now if I have this many moles, I'm going to figure out grams here of CaF2 made. I'm going to go back and use the original equation because I don't want to lose any decimal places. So there's my moles, and then I have to say for every 1 mole, CaF2 is oh, you guys, I used the wrong one here. This one is right, 100.02. Now, that's okay if this number's bigger because it will make this number smaller, so it's still the limiting reactant. But CaF2, that's the one I changed to 78.01, right? So for 1 mole of this, I have 78.01 grams. I'm sorry for the messiness. Let's try this again. 412.5 divided by 100.02 times 3 divided by 3. Yeah, this is 4.12 moles, but now I'm going to multiply it times 78.01 grams. So we will get, and I'm not sure about sig figs here, guys, 321.73 grams of CaF2. Now, on the other hand, I'm going to start with 412.5 grams of CaCO3, and I'll figure out how much aluminum carbonate I think that is. So again, this is okay. 100.02 0.2 grams in 1 mole of CaCO3. Now use the balanced equation. For every 3 moles CaCO3, I'm hoping this is balanced, is 1 mole of Al2CO3. Now I haven't done the molar mass of that one yet, have I? So aluminum is 2 times 26.98. I have 3 carbons there, don't I? 12.01. Oops, sorry. And I have 9 oxygen. Look at that. That's a big one. 2 times 26.98. 0.98 plus 3 times 12.01 plus 9 times 16. All right, I believe this adds up to 233.99 grams per mole of that. So, for every 1 mole of aluminum carbonate, I have 233.99 grams. All right, let's do that calculation. 412.5 divided by 100.2. Over here, another divided by 3 multiplied by 233.99. 321.09 grams of aluminum carbonate. Right, so that took some work, but we had to do a bunch of molar masses, didn't we, to get this done. So let's see if I can get part of this next one done. All right, how many grams of, oh, now we're going to talk about excess reactant, right? So first we figure out what's limiting. So we take 277 grams of Na2SO4 and 137 grams of Ca3P2. Well, we have to first get molar masses. I'm going to run out of time on this one, but we'll get it started. So sodium, I have 2 of them times 22.99. 1 sulfur at 32.01 and 4 oxygens at 16. Okay? Always check that I'm putting this in my calculator right. Okay? I believe my molar mass is 141.99 grams for that. Now down here, I have a calcium. Calcium is 40.01 times 3. And 2 P's. P is 30.97 times 2. All right, 40.01 times 3 plus 30.97 times 2. So the molar mass here of this guy, right, is 181.97 grams per mole. All right, I'm going to pick a product. Dang, let's pick Na3P. So 3 times sodium, 22.99, 1 times phosphorus, 30.97. Whoops, 22.99 times 3 plus that 30.97 gives us 99.94 grams per mole. So this is what product we're looking at. Set up our T-chart. So we have this many grams of sodium sulfate. So 141.99 grams in 1 mole of that sodium, right? We're going to that product. So every 3 moles of what we had gives us 2 moles of Na3P. And I guess we can go right to grams in here because it's asking there, right? And then 1 mole of this thing is 99.94 grams. I'm going to stop here, all right?